Hello friends, welcome to my home, and today we are finishing the rest of the first derivatives test, going over all the problems. So we start off with a straightforward, and this is where the first trouble cropped up, is this is just a straightforward limit problem. No derivatives need to be taken here. This is just limit as x increases without bound. Of a rational function, 2x squared minus 17x over 3x cubed plus 10,000. Generally, when you see rational functions and we're taking limit as x increases without bound, what we're looking for is the term with the highest degree. So that's going to be 2x squared in the numerator and 3x to the third on the denominator. And as x gets larger and larger and larger, this rest doesn't actually matter. So this becomes the limit as x increases without bound of 2x squared over 3x cubed. A certain quantity of x's cancel, and so we have limit as x increases without bound of 2 over 3x. And so when this fraction, as x gets larger and larger and larger, this fraction is going to get clearly smaller and smaller and smaller, so that means the limit has to be equal to 0. All right, no calculus required. That kind of tripped some people up, but this is just straightforward. Do you remember how limits work? Okay. This is probably the hardest question on this page. What is the absolute minimum value of y equals x cubed minus 3x squared minus, or plus 3x squared minus 3 on the closed interval from -2 to 1. So for this, just a general reminder, cubed functions look mostly like this. So we're going to want to see if we have any relative minima in the interval. And then once we've identified that, we need to look at the endpoints to see if there are see what the absolute minimum, relative minima. Look at the endpoints and see what the absolute minimum is. So to look for relative minima, we'll take the derivative. 3x squared plus 6x, 3 goes away. We set that equal to 0, which means that we have 3x times x plus 2. So x equals, so we have dy dx equals 0 when x equals 0 or x equals -2. And both of these are fair game. They are both in the interval. However, I happen to notice that, and this is outside information, this is just an extra kind of bonus that'll speed up the problem solving process. Since this is a positive leading coefficient, that means that the function has to look like that particular squiggle, which means that this first one is going to be a maximum, a relative max, which of course means that's going to be the relative min on the interval. But let's go through the motions anyways. We need to check at x equals -2, x equals 0, and x equals 1. So when we have at -2, y equals 2 cubed plus 3 times -2 squared minus 3, which is equal to -8 plus 12 minus 3, which is equal to 1. Then we have 0 cubed plus 3 times 0 squared minus 3, which is equal to -3. And then we'll check it at 1. Y equals 1 cubed plus 3 times 1 squared minus 3, which is of course 1 plus 3 minus 3, which is 1 again. This is the lowest value on the domain, so that means it must be the absolute minimum value. So that is our answer for this one. Okay, with this one, we want the limit as h goes to 0 of sine of x plus h minus sine of x over 2h. Now, as soon as you hear the phrase limit as h goes to 0, that should be the first hint that, maybe this is asking for the derivative. And then you look at this function, this repetition of sine, the fact that it's a subtraction, this is a difference quotient. This is asking about the derivative, but this 2 is a little bit different, but not that much different, because we can easily remove that. It's just multiplication, or in this case division by a constant. So this is just 1/2 the limit as h goes to 0 of sine of x plus h minus sine of x over h. And this expression here is the definition of the derivative of sine. So we just, to solve this, we just take the derivative of sine of x. That's going to be cosine of x. So this is 1/2 cosine of x, or if you like, cosine of x over 2. Both of these are perfectly fine. Now we're asked to find the equation of a line tangent to this curve, y equals 3x squared minus x minus 3, at the point 1, -1. Okay, if we need the equation of a line, you need two parts. You need a point, which we have a point, and you also need a slope. Now the slope of a line tangent is going to be the derivative at that x value. So we want dy dx when x equals 1. So we have to go through here. If y equals this, that means that dy dx is equal to 6x minus 1. And so when x equals 1, dy dx is equal to 6 minus 1, or 5. So now we have our point, we have our slope. We're going to default firstly to point slope form. So y equals the y value, -1, plus 5 times x minus 1. For that one. All right, once again, we have another. Find the equation of a line tangent to a curve. And this one is a trig one, and you might see, oh, they're multiplied together, or we can use the product rule. And you can use the product rule. But before you use the product rule, especially when we have two trig functions multiplied together, can we simplify this? And we ask ourselves that because, well, y equals cosine x, and then tangent is sine x divided by cosine x. Oh wait, cosine x, cosine x. This function is equivalent to y equals sine of x. As long as x is not equal to one of the multiples of pi over 2. Right? As long as it doesn't equal that, which, hey, it doesn't, we can simplify to y equals sine x. Great. So once again, it's the equation of a line. We need a point. Well, we have the x is pi. We should find our y. Y equals the sine of pi, which is just 0. Okay, so our point is thus pi 0. And we need our slope, which we get by taking the derivative. Dy dx of this nice simplified function is just going to be cosine of x. And so we take the cosine of pi. Cosine of pi is -1. We have our point, we have our slope, we write our equation. Y equals 0, but -1 times x minus pi. And this one is so simple, we might as well just simplify it a little bit more with have it equal negative x plus pi. Both of these are fine. I'm happy either way. But yeah, always when you're multiplying trig functions, always look for a possible simplification. It'll make your life better. And then our last for this test. If f of x equals the secant of x, then what is f prime of pi over 4? Well, we find f prime by just taking the derivative. Derivative rules, the derivative of secant is secant x tangent of x. And then we plug in pi over 4. Tangent of pi over 4, that's just 1. Secant of pi over 4, if you need help with this, it's going to be 1 over root 2 over 2. So that's going to be the same as 2 over root 2, which you will never see it written that way because it's got a radical in the denominator. If you rationalize this denominator the traditional way, with multiplying top and bottom by root 2, you get 2 root 2 over 2, because root 2 times root 2 is just 2. And these cancel. The end answer, the simplest form, is going to be just the square root of 2. And there you have it. That's everything on the first test.